Hello students, the continuation of properties of fluids. In that, today we are going to learn in this session surface tension and the examples of surface tension. Yes, surface tension. The statement says that it is measured as the force acting per unit length of an imaginary line which is drawn on the liquid surface. The direction of force which is being perpendicular to this line and tangential to the liquid surface. So we'll analyze the statement through the expression. See the diagram on the screen, children. You can imagine the line AB on the free surface of a liquid. If we have taken L is the length of the imaginary line, then the force F is the total force on either side of the line. Then we can say F, which is directly proportional to L, length. The force is directly proportional to length, or we can write the force which is equal to sigma L. The sigma is the proportionality constant of the surface tension we have taken. So sigma, which is equal to F by L. So that the surface tension we can say force per length. So SI unit of surface tension is Newton per meter. The CGS unit is dyne per centimeter. Dimensional formula, as we said, for all the phenomenon you must know. Dimensional formula, through the base formula force by length we can calculate. So force which is equal to, what is the dimensional formula? ML T power minus 2 by length L. So by simplify we will get M T power minus 2 is the dimensional formula. Now we are going to see how is the surface tension explained on the basis of the intermolecular forces. See the diagram, children. The molecular theory of surface tension, with the help of the diagram we can see P, Q or S is the surface film of a liquid. Now you can consider the molecule A. So well inside the liquid. See the diagram A, it is fully inside the liquid and it is attached equally in all directions by the molecules which lying its surface the sphere of influences. So the net force of the molecule is 0. Now you can consider the B, the molecule B which is lying inside the surface film. Its sphere of influences actually lies partially outside. See, very little it is coming outside. So this molecule which experiences less force which is upward and more force which is on downward direction. See the molecule C, the half its sphere of influences lies above the surface. So the resultant downward force on such a molecule is maximum. So due to this downward force, the potential energy of the molecule of the surface film is higher than those lying well inside the liquid. So you may compare the molecule A and C. So due to this downward force, the potential energy of the molecule of the surface of the film is C is higher than those lying well inside A. So for a system to be stable, the potential energy must be minimum, right? For the surface film to have a minimum energy, the number of molecules is inside that must be minimum. So thus we can say the surface film tend to have the minimum surface area. As a result, the free surface of a liquid at rest behaves like a elastic stretched membrane. Right. See some examples which illustrate for the extension of the surface tension, children. See, we have the first one is an example of the needle which is supported on water surface. This you can try it in your home also. See a needle which is floating on water. That is, you can take a greased needle. That is, you can grease it You can use oil also for that. So the greased needle of steel on a paper of blotting paper, and you can place it gently over the water surface. The blotting paper may soak inside the water and soon it sinks down, but the needle keeps floating. The floating needle causes a little depression. See the force F due to the surface tension of the curved surface or inclined, like you are seeing on the screen, the diagram. The vertical components of these two forces which is supported the weight of the needle. You really tried in your home, children. You will definitely get the needle supported on the water because of the surface tension. The second example, that is endless wet thread on a soap film. If you take a circular frame of a stiff wire and dip it into a soap solution, a thin film which is framed on the frame actually. If a wet endless thread loop is gently placed over the film, it takes any irregular shape. But when the film is pricked at the center, the loop is stretched outwards and takes symmetrical circular shape. This is because of the given length a circle has a maximum surface area, and so that the outer liquid film tries to occupy the minimum possible area, like a stretched elastic membrane. As we said, the free surface of a liquid at rest means it will behave like an elastic stretched membrane. See another example of illustrating the surface tension. See the first diagram, the hair which is cling due to the surface tension. See the hair of the painting brush, you may see that, cling together when taken out of the water. See when the brush is taken out of water, the hairs cling together because due to the surface tension. This happens because of the free surface of water which tries to acquire a minimum surface area. And see the second diagram, a bug which is supported on water surface by surface tension. See, as seeing on the diagram, the bug which bends its legs on the surface of the water such that the deformed surface which gives rise to forces of surface tension which act tangential to the deformed surfaces. The weight of the bug is balanced by the upward components of these forces of surface tension. Right. Now, we can show that there is always excess of pressure on the concave side of the meniscus. Through the pressure difference across a curved liquid surface, we can see the diagram, students. When the free surface of a liquid is curved means there is a difference of pressure between the liquid side and the vapor side of the surface usually. Now we can consider three different possible liquid surfaces. First one, PL which is equal to PV. That means if the surface is plane, the molecule A on the surface is attached equally in all directions. So the resultant force due to surface tension is 0. So the pressure on both sides of the surface is same. So PL which is equal to PV in the first case. The second case, if the surface is convex, there is a resultant downward force F which is on the molecule A. For the surface to remain in equilibrium state, the pressure on the liquid side must be greater than the pressure on the vapor side. So PL is greater than PV. See the third case, students. If the surface is concave on the diagram, there is a resultant upward force. See the force direction due to the surface tension on the molecule of A. So for the surface to remain the equilibrium state, the pressure on the vapor side must be greater than the pressure on the liquid side. So PV is greater than PL. Right? Yes, students. So far we have learned from this session elaborately about what is surface tension. With the example we have seen how the molecule will be there if suppose inside the liquid, half of the liquid it was there outside, then how the velocities and because of the surface tension how it will be worked we have seen, and different examples with the illustration we have explained. You may understood very clearly. Thank you students.